Now we are going to see case by case what happens if my IF is going to be very high. What happens if my IF is going to be very high? See here, you have an LNA followed by image reject filter, then your channel select filter. So image reject will reject your image and channel select will select your message signal. Okay, channel select will select your message signal. So see here, this is the frequency diagram. You have omega in is your desired channel and omega image, omega IM is somewhere far away. Difference is 2 omega IF. And when you use image reject filter, this image is gone. And when you use channel select filter, the channel is selected. But see here, we have an interferer very close to my channel, which is still available in the receiver side. So this image reject filter will reject your image alone, but the channel select filter, even though the interferer is very close, the filter has to be very strong enough to reject the interferer also. So very high RF IF allows substantial rejection of image, whereas you cannot help with the in-band interferers. So if the interferer is very close to your frequency band, sometimes the filter may work well, sometimes the filter may not work well. It depends on how close the interferer is going to be with your message signal. When you have a low IF, when you have a low IF case, see here, when the image frequency is very close to your message frequency, you have first the image reject filter. Naturally, this image will be filtered, and when you are going to have this channel select filter, it will also be filtered. So you cannot say whether high IF will solve my problem or low IF will solve my problem. In both the case, the in-band interferers will always be there. Maybe you can cancel out all the image frequencies, but there is going to be always a trade-off between image rejection and channel selection. In both the cases, image rejection has happened very well, but channel selection, you have the interference. In the previous case, my interferer was there. It is not completely filtered, but here you see it is somewhat the interferer is completely filtered out from my band of channel selection. So there we cannot say whether image rejection is good or channel selection is good. It is always going to be a trade-off between image rejection and channel selection. Now to overcome this problem, we are going to go for dual down conversion. So as you know, whatever architecture we have seen, a single down conversion from RF, we are converting it into IF. RF minus LO is going to be equal to IF. So since we have seen that this trade-off is going to be very severe, and also the image can be suppressed only when the IF is very high. We have seen the condition. To solve this issue, we are going to have multiple down conversions. So heterodyne, we are going to have multiple IF, multiple IFs. So when you have multiple IF means you'll have multiple LOs and multiple mixers. Okay, so this techniques illustrated, this technique, whatever we are going to see, it will relax the burden. It will relax the burden on your filter. So we have seen in the previous case, the filter sensitivity has to be very high, right? So if we are going to have the filter do its job alone perfectly, that is possible by having multiple heterodyning. Even though I am going to spend so much extra on all the mixers and LOs, I don't feel for that because ultimately my image suppression is only going to be my ultimate aim. See here a simple example of dual down conversion. You have one band pass filter, LNA, image reject, mixer. This is your one IF. Next band pass filter, mixer, channel select. Finally your IF amplifier. So you have two down conversion. Or mixer இருந்தா one down conversion. Second mixer, second down conversion. Okay. So this band select filter will select your desired band of frequency. Image reject, you know, it is to reject your image. Mixer, sum and difference. Again, select your channel alone. Again, sum and difference. Select your channel alone. Go for amplification. So see here, you have desired channel and image, and at point A, you have this is signal coming. After selecting your band, you have these two are gone. I'm going to pick frequencies only from this. So that goes into the image reject filter one. So this image is rejected. See here, and the remaining signal goes there. And again, I'm going to go for channel selection. So again, these three will be there. And I'm going to go for again mixing. This is channel selecting. Again, I'm going to go for mixing. So when I convert from high frequency to low frequency, and I'm going to use my channel select filter, the amplitude of interference is going to be completely suppressed, and my desired signal is boosted. And after the amplifier, after the IF amplifier, you see the noise is completely removed, and you have the maximum amplitude of your desired signal. Two IFs are involved here because I have two mixers. So remember the logic, number of mixers equal to number of IF frequencies. So two mixers I have and the two IF frequencies I have. Definitely this IF1 will be greater than IF2. And omega LO1, omega LO2 depends on what you choose. It they may be same, they may be different. It depends on what application you are going to use this for dual down conversion. A simple example how we can reduce the burden on all the filters operating on my circuit to ensure that finally my image is going to be completely suppressed.